What is what? It's in your formula booklet. Where's the formula booklet? Oh, jeez. It's that one, but less x's.
1 minus x squared over 2 factorial.
Yeah.
To the power of 4 factorial.
Okay. So let's first of all remember how we do cosine 2x then. We would.
Substitute 2x in all of them.
Okay, so let's make sure what's on the board is correct then. Is 2, yeah. Okay. Do we need to do one more? Yes. 2x6 over 6 factorial. Someone's going to have to help me out with that. But let's leave it as 6 factorial for now because we'll do some cancellations in a second. 1 minus 4x squared over 2 plus 16x4 over 24 minus 2 to the power of 6. Anybody? 64. 64x 6 all over 6 times 5 times 4 times 3. For some reason I'm doing it this way just to be awkward. I know that 4 times 2 is 8. And 8, 4, and 2 goes into that. 4 and 3. That's it. We got it. Okay. Let's simplify this up then. Minus 2x squared when we do a bit of cancellation here.
Is it 16x or is it 8 and 3? It's 16.
Okay. 16 or so 2/3 x4 over 3 and 4x6 over 9 times 545. Yeah, we got there. Okay, so that is the representative of cosine 2x. If you're asked to do that up to the x to the power 6 power. No filleting today? No? Okay. Use the first few terms now as the second part of the question. Use the first few terms of sine x. So sine x they give us is this one. 1 minus 1/6 x cubed. They do out the factorials for us. They write it like this, 120 x5. That's as far as they go. Use this to form sine x squared up to x6. Can we just sub in x squared for x here? So they're looking to form this, write this as a polynomial using Maclaurin series. Up. Yeah, you've fallen for the trap there. No.
Well, no, it's squaring the sign.
Yeah, it's squaring the whole thing.
Yeah.
So every term you wouldn't square, like if I said, if you had a binomial bracket, you wouldn't just say a plus b squared is a squared plus b squared, would you?
Would you do the sigma notation?
No. So we have a full polynomial here. So that's a bunch of things we got to multiply by each other. So sine squared x can be rewritten sine x squared, which is sine x times sine x. So this is where we need to think about what would need to multiply by what to get up to the x6 term, which is what the question asks for, up to x6 term.
The second one is square root x cubed squared.
Yeah, okay, so we can set this up a little bit. If I move this over a little bit, sine x to b squared is 1 minus 1/6 x cubed plus 1 over 120 x5 times, times it again. 1 minus 1 over 6 x cubed plus 1. Am I right?
It's not 1.
Oh yeah, of course, because it's x cubed, x5. Oh yeah, my bad. X 120, x5, all the way up. So we just got to do polynomial multiplication here. We got to think of everything that adds up to the bits we want. I think x times x gives x squared. X times this, well, we just, this is my suggestion, go as far as all multiplications that include x6 and then tidy it all up afterwards. I can't think of a quicker way. Minus 1/6 x to the 4 So I'm multiplying by x each time here. 1 over 120 x to the x to the 6 now, because x times x to the 5. Yeah, I think this is probably the quickest way. What do you reckon?
No way, that's the quickest way. Probably is, unfortunately.
Oh, you could go faster then. Abby, I challenge you. This times this one is going to give another minus 16x cubed. Or x4, sorry. They're all going to be even powers now. This times this one will also be included. Plus 1/6 times 1/6 is 1 over 36 x6. So that's that times that. This one times that won't work. So this one times this will work though. Plus 1 over 120 x to the 6 as well. That's this one times that. And have I any more to do? That's it, I think. So I've done this one times these 3, this one times the first 2, this one times this one, and then I think we've got all those multiplications. So just an addition of like terms here, we have x squared, we have minus 1/3. We have 2/6 here, so that'll be 1/3 put together, x4. And then perhaps writing this as something over, can we write over 120? 4, no, 5, no, it's not going to work. Common denominator, 160. Anyone get there faster than me?
No, we can't.
You got it. All right, this is 3 over 360 then. It's the only thing I can think of. I presume that's maybe our best bet.
Yeah, I think that is the best thing.
3 over 360, and that's 10 over 360. So we get 16 over 360. 16 over 360 can simplify down to, well, 4.
8 over like 180.
8 divides, no, 4 divides into both of them.
Yeah, 4.
So that's 4 over 90. 490, it's, oh, we can go again. 245s, okay. Plus, yeah, they're all plus, yeah, plus 2 over 45 x6, okay. So we got there. Let's hope this is the kind of stuff that'll slow you down on exam day where you have to add fractions that are not quite nice. You need to practice getting speedy at those when you do your exam revision. Okay, we've done that. Compare your result to 1/2. So we want to compare to this. Why do you want to compare to that? We want to compare this result, which is the result for sine x squared, to this. Well, we got this already. This is a representation of cosine 2x.
Yeah.
Expanded out. So if I just replace cosine 2x with that, minus 1/2 times all of this, 1 minus 2x squared plus 2x4 over 3 minus 4, 45x6, tidy that up, and then we compare it to this. So everything's got to be halved. So that's 1/2 minus 1/2 plus the 2's plus x squared. The 2's cancel here. And that's going to be 2 over 6, which is 1/3. 1/3 x to the 4. And that's going to be 2 over 45 plus 2 over 45 x6. And the halves here cancel. And we have the same answer, but a different sign for x to the 4, which means I've done something wrong somewhere. Oh, this one's wrong, because that's a minus 1/2 times this, which is minus. So they're the same. Why are they the same?
Because we get sine squared x. Is that one of those trig identities?
Yeah, there's a trig identity that links these
Or
two.
is it cosine x?
I think if we look at our formula booklet and we look at the trig identities,
I don't have it.
which I'll find somewhere very slowly, we've a link between cosine, well, 2 theta is in the formula booklet, which is the same, is equal to 1 minus 2 sine squared theta. So if I want to change this around, perhaps this over here or something, if you want to have 2 sine squared theta as the subject, you could rearrange this and write it. And then half everything. Sine squared theta, half, and half of this would just be half. Well, yeah, it should work out if it follows all rules. Yes. Yes. Okay. So the key thing here was we're dealing with multiplication. Well, we did some substitution here, but that was already given in the question, but we're testing it. Key thing when doing multiplication is you can just write them alongside each other, and they're just long polynomial multiplications. Just make sure you cover everything multiplied by everything else. Your turn.